session. Okay. Now, going to question 2. You wanted the first name and last name of a person. Since these are strings, there is no conversion needed. So first name is input, enter first name, last name is input, last name. And then you wanted to prompt the user to enter the number of classes taken by this person. So you concatenate the first name and last name, and that is essentially what you display. And then you read the input as an integer and store it in number of credits, and then you print out the information of the number of classes actually. So this is a bad name. It should actually be number of classes, not number of credits. Then the third question is in some sense, the most difficult. So let me explain this a little bit. So let me stop sharing here. Or actually, let me go ahead and copy the code and then stop and do a different share. Let me copy the code and explain to you using the whiteboard what is happening. So here, I'm going to okay. That probably is everything that I have in the, let me just, or maybe not. Okay, that is the code. Okay, let me explain the solution here. I import turtle. Okay, and you remember the problem. The problem was to actually first draw a circle, I think at 50 minus 50. 50 units to the right, and 50 units bottom, I think, this way, 50, that is the center. And we wanted a circle. Okay, we wanted a circle here. That is all blue colored. That is what we want. And then we wanted a circle wherever the user specified. Let's wait on that. Let's just see how to draw this circle. So you want the center to be at 50 minus 50. So let's see how to do that. So we want a circle centered at this point. So we take the pen up, or put the pen up, hide the turtle. I don't want to see that turtle. And then I go to 50, 0. So I'm going 50 units to the right, but I'm not going down or going up. I'm staying here. So this is 50, 0. Closely follow what is happening. So I'm at x50, y0. So that is here. Then I put the pen down. So whatever I draw now will be shown. This is crucial. I set the heading to 180. So I set a direction for the turtle, which is to go left. So the turtle is traveling left now. Not that it is moving, but its direction is west. 180 is west. And then I set the color to blue so that the filled circle will be in blue. Then I begin the fill, and now I create a circle, draw a circle with radius of 50. So I will be drawing a circle, but the question is, where is the center? The center would be these many units. This is 50, right? So 50 is the radius. So 50 units, that is pixels, to the left of the direction I am traveling. I am traveling west. So the left, so if I'm going this way, if I look left, it is here, the southern direction. So it will be the center will be 50 units to the left. So it will be at 50, negative 50. And then when I draw a circle, it will go like this, and it will be filled. Actually, it will be right here. Okay. I did not insist that I mean, when I was grading, I did not really insist that the center be exactly at 50, negative 50, but I wanted it to be blue and have a radius of 50. And many of you got this right. The second part of this is more difficult because you have to know exactly how to position the turtle to draw the circle at the given radius. So let me erase all this. And I was more insistent on you're getting it right. So many of you lost points. Oops. Let me see if I can recover what I have here. Yeah, all right. Okay. So this is my coordinate system. And let's say the user enters some X and Y values. Let's do it with X equals negative 70 and Y equals negative 30. So this is negative 70. And since we have Y equals negative 30, we are saying the Y coordinate of the center is negative 30 here. This is X equals. So the center will be here. And let us say we have a radius of 20. So it would be somewhat like this. Okay, let's imagine those values to understand the code. So X is negative 70, Y is negative 30, radius is 20, and we lift the pen up, then go to X comma Y plus radius. So we are going to X is negative 70, Y is negative 30, and radius is 20. So X comma Y plus radius would work out like this. We are going to X equals negative 70, Y equals negative 30, radius is 20. So we'll be going to negative 70, negative 10. So we are going to go to negative 70 and then -10, which should be this point. So we lifted the pen up and went all the way here. The turtle is right here. This is where the turtle is. And then we set the color to black so that a black circle will be drawn, but we are not going to fill it. So inside it will be all white. Then we set the heading west again. It could have been other directions, but then I need to go to different places. So in any case, I am setting the direction to west. So I'm traveling west. Now, if I draw a circle, the center will be to the left of where I am traveling. I am traveling west. So the center will be to my left, which is south, and it will be 20 units because radius is 20. It will be 20 units to the south. So this will be the center of the circle. So which is -10, -20. So it will be -30. And that is what we get. The circle will be centered at -70, -30. So many of you did not get the right center here. Some of you did, which was very good. Any questions? Okay. All right, let me stop sharing. I apologize, I haven't updated the grades correctly for the exam. I will do that this morning. I cannot say exactly when because I have to also help you with your class exercise and lab. So I may not be able to do it until my office hours, but I will, it escaped my mind to get that straightened out. I will fix the grades on the grade book sometime this morning, or maybe by the end of my office hours. I would ask you to go to the grade to the multiple choice part yourself and look at the answers. Let me see what the status is with respect to that. Let me go ahead and, or maybe I will work on it a little later, so that I can get those grades transferred as well. Now let's focus on this week's material, which is a new topic. And the topic is selection statements. Where do I clear this? Okay, so we are going to look at selection statements. So far, we wrote program with number of lines of code, one after the other. So this is the physical code, physical layout of the code. So you wrote Python programs, number of lines of code, one after the other. And the program started from the top, executed line by line until it reached the end. So for example, you might read the price of gas at station 1, then you had the code to read the price of gas at station 2, etc., etc. So the actual execution followed the physical position of the various lines of code every line of code was executed and the process continued until the program was over. But with selection statements, you conditionally select code to execute. Not every line of code will get executed. You pick and choose, saying, should I execute this line of code at all? I examine the situation, what is happening with respect to the program, the variables, what the user has entered, etc., and then decide whether a certain line of code should be executed. So it would work like this. For example, let's say we have read in the price of milk. Price equals float input enterprise. Okay, so the price of, say, milk is in this variable. So this gets executed. Now you can write, if price is less than, let's put some value, 4.0, you put a colon, you write quantity equals 2. Otherwise, you write else quantity equals 1. That is what I'm trying to do is, if the price is less than $4, I will buy 2 units of this, maybe 2 gallons. Otherwise, I will buy 1 gallon. And here I can write print total cost price times quantity. So what will happen here? I read in the price of milk. Let's say it is $5. Let's imagine that the user entered it is $5. Then I check. This is an indication that we are going to check something. If it is the case, what is the case? Price is less than $4. The value of price is $5. 5 less than 4. No, that is not true. If this is not correct, if this is not true, because 5 is the value in price, so this is not true, we will ignore this completely. This will not get executed. We will not select this. Instead, we will go and select this for execution. Quantity would now be 1, and we will print total cost is price, which is 5. Quantity is 1, because we set quantity to 1 here, and we will print $5. On the other hand, suppose we had a price of milk as 3 instead of 5, $3. If price is 3, which is less than 4, we will select this. So select this. Quantity would now be 2. We will ignore this completely, and then so they will not be selected for execution, and we will print total cost is price, which is 3. Quantity is 2, so we'll print $6. So that is an example of if statements, selection statements. You can also write more complicated versions.
I just had a quick question.
Yes, please.
So you said if price was 3, then quantity is you said 2.
Correct.
And then you print 3 times 2, which is going to be 6.
Correct.
Okay, thank you.
Let's make this a little more complicated. Okay. I'm going to probably erase everything. That's easy. Or maybe not erase everything. Okay. I could write more interesting things. I could write if. Give me a second. Let me adjust this. You could write if price is greater than $5, I would write quantity equals 1. Else, if price is greater than $4, or let me put it slightly differently. If price is less than $3, so that I can use different kinds of things here. That's the reason. Okay. Less than $3, quantity equals, let's say, 4. Else, quantity equals 2, maybe. Sorry, there should not be a semicolon here. Quantity equals 2. And let's say price times. Let's just print price times quantity. Let's see what this will do for us, how this will be executed. Let's assume price of milk is very high, like $6. If price is 6, we will come here and check. If that is, let's check. Price 6 greater than 5. 6 is greater than 5. So this is true. We will set quantity to 1. We will ignore everything that is under the else. Everything under the else is indented like this. So all of this is ignored. None of this will get selected. All are just left out of the execution process. This is the statement that gets selected because price is 6. Everything under the else is gone. Gone meaning ignored. And you can see that this, yeah, go ahead. Any questions?
Yeah, I'm sorry. So you said total cost times the price. So I just want to understand this again.
Yeah, where are you having questions?
Like from the beginning.
The beginning. Okay, we are reading the price of milk here. Let's assume that this stuff is there. Okay.
Okay.
So we are reading the price of milk, and that price is stored in this variable price. I know I have erased a little bit here, so but assume that this is price. So price, let's say, is 6. Then we are checking is if price greater than 5. So price is 6. 6 greater than 5. So that this is considered true. That is a true fact, right?
Oh, okay.
So since price is 6 and it is greater than 5, quantity will set to 1. Yeah. And then we will ignore everything under the else. This is like otherwise.
And quantity is already 1. Okay.
Quantity we set to 1, right?
All right. And ignore the else's.
We ignore everything under the else, correct? None of this will get executed.
Okay.
Okay.
Thank you.
So that is, that is why this is called a selection statement. You're selecting things based on the values of variables.
Professor, I also have a quick question.
Uh-huh.
How many else can you have?
You can have, okay, for an if, there can be just one else, no more than one. But you can have many else's. Okay, it's a good question. There is an else here, which is associated with this if. And this else is associated with this if. So for every else, there has to be a corresponding if. And an if can be only associated with one else. Okay. Without an if, there is no else. Does that make sense? For example, if you don't start an essay saying otherwise, right? I mean, you have to say something and then say otherwise, right? Similarly, else is also like otherwise. So if you write else, there has to be something that you checked. If that is not the case, that is what this means. That's what this means. That is, price is less than or equal to 5. You see that? If you have an else, there has to be a condition that you check. If that is not happening, then we do all this. So the moment you hit the else, you know that price is less than or equal to 5. So now if you are under the else, you can check, is price less than 3? You are guaranteed that it is less than or equal to 5 the moment you come to this part of the code. Because if price was 5, more than 5, you would have executed quantity equal to 1, and none of this will even be considered. So the moment you get to this part, you know that price is less than or equal to 5. So now you check, if price is less than 3, then you set quantity to 4, but then there is an else here which is associated with this if. So you have an else here, an else over here too, but they match different ifs. This else is for this if, and this else is for this if. The rule is an else matches with the most recent unmatched if. That's a lot. For every else, there has to be an if, and it matches the most recent if. That is unmatched. So you check here. What is the most recent if? It is this one. Has it already been matched? The answer is no. So this else matches this if. And when you look at this else, it matches some if. So you look for the most recent one. So you keep going up. Yeah, okay, there is an if here. Has it been matched? No. Now this has been matched. It cannot match another else. Okay. And when would you come here? When would you set quantity to 2? Suppose price was $6. Would quantity be 2?
No, it would be 1.
Correct. Let's try a few other things then. $5.
The quantity it would be 2.
Correct. Why is it 2? That is a very good answer. If it is 5, this is not true. 5 is not greater than 5. So this will be ignored. You will come to the else. price less than 3? The answer is no. Price is 5. So this will be ignored, but then the else part of this will be hit and you will set quantity to 2. So what if price is $3?
It's not greater than 5.
Quantity would be
1.
if price is 3.
Uh,
If price is 3, what will happen here?
It'll be incorrect. It'll be incorrect.
Be 2.
I'm not hearing properly. I'm sorry.
It will be incorrect.
It'll be, you say actually it'll be false.
Yeah, sorry.
3 greater than 5 is false. It is wrong. So it is, in computer terminology, it is false. So that value is called false. Okay. So price greater than 5 is false. So quantity will not be set to 1. We are assuming price is $3. So if price less than 3.0, is this true or false? Price is 3. 3 less than 3.
False.
False.
False. So that is also false. So quantity will not be set to 4. So it will hit the else, which means quantity will be set to 2. Okay. Is that making some sense now?
A little bit, yeah.
Okay. There is another thing that I will touch upon, and then we will look at the lab and then do the class exercise. Let me probably erase all of this. And then let me again write price equals float input. Okay, if price is greater than 6.0, quantity equals 1. You can write else, or you could also write L if. What it means is, if price is greater than 6, you will hit this. Otherwise, you can check another condition. If price is greater than 5.0, quantity equals 2. L if price is greater than 4.0, quantity equals 3. You can keep on writing like this. L if price is greater than 3.0, quantity equals, let's say 5. Else quantity equals 7 or something, right? So what does this mean? You ask for the price, and if that price is more than 6.0, let's say 7, you set quantity to 1, all of this would be ignored. This means else if. So this will be ignored, this will be ignored, this will be ignored, this will be ignored, everything else is ignored. Let us then pretend that price is $5.50. If price is $5.50, this is false. So you come here, this is called, I have written it as elif. What it means is, if the condition is false, if this condition is false, and if this condition is true, else if. This really means else. Otherwise, if price is more than $5, so we assume price is 5.5. So price is 5.5 greater than 5. So we will set quantity to 2. and all of this will be ignored. So now suppose price is 4.5, then we will be ignoring this because price, sorry, let's say price is 4.5. This is false, so this is ignored. Then we come here, we check if price is greater than 5. Price is 4.5, greater than 5 is false, so we will not set quantity to 2. Then we check if price is greater than 4.0. Price is 4.5, greater than 4.0, so quantity will now be set to 3. And this will be ignored. What if price is 3.5? Suppose we get 3.5 here. What will happen?
If price, so you said if price was 4.5, like the first two will be false, but the third one will be set, the quantity will be set to 3, and the rest will be.
Price is 3.5.
The first two are false.
Yeah, this is false. This is false. What about this? Price is 3.5.
So
False.
that's true.
Price is 3.5.
Oh, false.
It'll be false.
Yeah, so it will come here and set quantity to 5. Now let's say
And we ignore
price
some.
is, sorry.
And we ignore the else.
Yeah, we'll ignore the else too. Now, so let's say price is $1. 1.0. Will this be true?
It'll be false.
How about this?
False.
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 So it will hit this. This catches all the other cases. On the other hand, so quantity will now be set to 7 if price is $1. If you didn't have this else, quantity will not have a value if price is $1. So you have to be careful with all this. Any questions before we go to the lab? All right, if you don't have questions, let's look at the lab. And
Professor, I do have one quick question.
yes,
Are we not doing a class exercise this week? Just the lab?
we are doing class exercise.
Oh, okay.
I want to show you the lab. There are some aspects you have to be very careful with. So it is lab 5, which is here. The problem is like this. If you know the mass of a substance, it is measured in kilograms. And if you multiply it by 9.8, you get the weight, which is in newtons. So mass is in kilograms, weight is in newtons, and this is the formula. So let's read this. Write a program that asks the user to enter an object's mass in kilograms, then calculates its weight in newtons. So given the mass which the user is going to enter, you need to compute the weight. If the object weighs more than 980 newtons, that is the weight is more than 980, the program should display the message, the object is too heavy to be lifted. So it is the weight that you need to compare here, obviously indicating that it is too heavy to be lifted. Otherwise, it should display the message, the object can be lifted. So suppose the weight is 5 newtons. What should be the, what should it display? 5 newtons.
It would be 49.
No. It is the weight, not the mass.
It's quite light.
No,
Oh, sorry. Yeah.
it is the weight, 5 newtons, not the mass.
Oh, the weight of 5 newtons.
Suppose the weight is 5 newtons.
Yeah, it says if it's under 98 newtons, the object is quite light.
But what does it say here?
I would say the object can be lifted as well as the object is quite light.
Exactly. If the object weighs more than 980 newtons, the program should display this. Otherwise, it should display this message. When you read these things, be very careful. Don't just assume things. Otherwise, it should display the message the object can be lifted. So this is true for all weights that is under or equal to 980 newtons. If the object weighs less than 98 newtons, the program must display the additional message. Some of you will get this wrong if you are not listening to me, okay? The object is quite light. So the first step that you need to do is understand the problem and fill out this table. So the weight in newtons is given here. You must fill out this table. What are the messages that should get displayed? You can put a check mark. Then you need to write the pseudocode for reading in the mass. Then what should be calculated? And then you must fill in this table. So this is the test data, mass in kilograms. You must write 5 different masses, their corresponding weight in newtons, and then what messages will get displayed. You may get confused with this. So let me explain this column. Suppose I test it with, actually I can't write into this because it is on the net. So let me go ahead and do it on the whiteboard. Okay, let me. So listen carefully here. You have mass, weight, and then why this test? Why are you testing it with this mass? Okay. Suppose the mass is, let's pick some number like 1,000 kilograms. The weight would be 9.8 times that, which would be 9,800. Okay, that would be the weight. Can this be lifted?
No.
No. So can be lifted? No. So why are you testing this? Because you want to test whether it will actually catch situations where the stuff can be, the stuff is too heavy to be lifted. So very heavy objects. Okay, so there is a motivation for doing this test. Okay, you're allowed 5 tests. So suppose you try it with a mass of 2,000, then this will be 19,600. Okay, that will be the weight. Can this be lifted?
No.
Okay.
No.
No. Then what are we testing here? We have already tested for very heavy objects. So if you want to test it again, you must write very heavy objects. Okay, fine. That's okay. I mean, then suppose you test for 3,000. It is again very heavy objects. Suppose you test for 4,000. You have very heavy objects. 5,000. It is again very heavy objects. But you are allowed only 5 tests. See, none of us have infinite amount of time. We need to finish this testing at some I mean, at some point in time, right? So we can't keep on testing. So if you test only for very heavy objects, you will never finish testing the program. So you must test for different things, very light objects, very objects that are not too heavy or too light, but can be lifted, and so on. Also, if you go back to that problem statement, there are situations. Okay, let's go back. If you go back here, you will see interesting situations. If the object weighs more than 980 newtons, so you must check for, ideally, you must check for exactly 980 newtons. With 980, would it display this or this? So that is what is called a boundary condition. Similarly here, 98, if the object is more than 98, it should not display this message. If the object is 98, what should it display? Should it display this or not?
It should not.
It should not, exactly. So those are called boundary conditions. You must check those kinds of things. So that is why we need multiple test cases. If you don't test something, you probably won't catch certain bugs. And so be careful with all those kinds of things as you are doing the lab. Be very careful when you fill this table, because some of you might go wrong. Then there is another aspect which I don't want you to be too worried about. You will get some errors in your code. It is not, which is not your fault. So I wanted to talk about that for a couple of minutes and ask you to ignore those kinds of issues, because they are too difficult to solve at this point in time, and we don't want to. Okay, but what is that I'm talking about? Okay. So when you multiply mass by 9.8, and that is weight, sometimes, suppose mass is, let's say, I'm just taking some examples, all right? 100 times 9.8, the answer is 980, obviously, right? But if you compare this against 980, so that is, if you write, if weight is greater than 980, it may not do the comparison correctly, because this may not come out to be exactly 980. When you do the multiplication, sometimes Python would be getting things like 979.9999999, okay, this kind of stuff. So if you compare this against 980, if weight is equal to 980, for example, Python would have computed 979.9999999 to a large extent, and then it will not be equal to 980. So